Audio Jungle. Audio Jungle.
Hello everyone, myself Narendra Singh Maurya and hope you all are doing well guys. So today we'll solve GATE 2011 performance problems. Okay, and this is problem number 14. So here it is given in an unpowered glide of an aircraft. Okay, having weight W and lift L and drag D, the equilibrium glide angle is defined at. So very nicely here it is mentioned it is an aircraft. Okay, it is an aircraft. So you just try to understand because what is the mean of the if term will be used. Suppose this is the one aircraft. All right, this is the aircraft here, and this is the aircraft. So you guys know what are the forces acting over the aircraft once it is simply flying condition. So definitely this will be the because the aircraft is what moving in this direction. So drag will be just opposite to the motion. Weight it will be downward force. Okay, and here we have a lift force which is vertically upward, and this is the thrust force which is propelling force of forward motion. All right, so this is the one case which is called steady level flight. Steady level flight, we all know what is the condition for the steady level. Thrust is equal to drag and lift is equal to weight. So this is the normal condition of the aircraft. But there is one situation when that aircraft becomes unpowered glide. So what is the mean of it? Simple. That aircraft was supposed flying, and that power is what turned off. Power is what turned off. Engine is what you can say turned off. So definitely thrust will be zero. So that time, what will be the motion of the aircraft? Okay, that will be called unpowered glide condition. So it is the aircraft. Okay, many times that problem will be asked. Sometimes like will be given like one glider. So that glider is obviously it's the unpowered vehicle. Okay, but here it is clearly mentioned an aircraft having weight W, lift L, and drag D, but it is now unpowered glide condition. All right, so hope you understood this. So now the same aircraft we can draw another diagram, which is in gliding mode. All right, so I can say, oh, this is the you can draw like no problem. No? So just say this gliding angle is what gamma. Yeah. And obviously weight will be acting downward. So this will be the downward force. And here that gliding velocity is what v here with free stream velocity you can say with free stream velocity v. Okay, v infinity you just say. So perpendicular to the v infinity lift we have L, and obviously this is the W, so this angle will be gamma because this is the gamma. So here this is nothing but W cos. All right, and this component, this side component, it will be W sin gamma. Hope you understood. Opposite to the forward motion will have drag. You know this, okay? So this is called gliding. This is the unpowered gliding. So unpowered gliding means what? Simply you say thrust is what zero. Hope you understood now. So they are asking what is the glide angle. So simple the same diagram you can understand in this way. This is what gamma, where gamma is nothing but gliding angle. Aircraft is what here you can say this is the aircraft now. All right, this is the W. Lift will be perpendicular to the motion of the aircraft. This is the motion of the aircraft V infinity. So perpendicular to that V infinity we have lift, and opposite to the V infinity we have drag. Obviously forward will be thrust, but thrust will be zero because it is unpowered. So this component, you can say this is gamma, so this will be W cos gamma, and this will be W sin. If you resolve the forces, then what you will get? D is equal to W sin gamma and L is equal to W cos gamma. What will be tan gamma? Check. Tan gamma is nothing but D by L. Simple. What will be the gamma? It will be tan inverse D by L. So where gamma is nothing but glide angle. All right. So simply here it was asked what is the glide angle. So check option A, tan inverse L by D, which is wrong. Tan inverse D by L, which is correct. Tan inverse L by W, wrong. Tan inverse W by L will be wrong. Because you have derived here. Okay. So that you know, that formula you should know. But anyway, here we have derived. So what is the correct answer? Correct answer is nothing but tan inverse D by L. I hope you all understand this. All right. Now we'll go for the next problem. This is the problem number 15. It is asked for 1 marks, and it is 2011, right? Now see, what is the question? Lift on an aircraft climbing vertically up. Climbing vertically up. So see, this is generally climbing case. If you go, this is the climbing case for the aircraft from the like base. It is a climbing angle. I can say this gamma is climbing angle. Depends, gamma or theta, anything you can read, take. So I say climbing angle. All right. So this is the climbing angle gamma. So that gamma can be anything. I mean 10 degree, 15 degree, 12 degree, 18 degree, 7 degree, anything. But here what they have said, this is the climbing of a climbing flight, but with given angle gamma. Okay. But here what they have mentioned clearly, it is clearly mentioned it is vertically up. So what is the mean of vertically up? So vertically up means see, this is the vertically up. That aircraft is what? It is going vertically up with V infinity. Try to understand. So just perpendicular to this V infinity will have lift force here, and obviously that downward force will be weight. Okay, just like for this, huh? If this is the V infinity, so perpendicular to this V infinity will have a lift force. Weight will be acting downward. Yes or no? Forward motion just opposite will be drag, and this forward direction force will be thrust. Yes or no? And we'll take component here. What will be the component? Gamma this. So this is W cos gamma, and here we'll get again, you can say W sin gamma. So that is the case, climbing case. But here it is vertically up. So forward motion is what this is the forward motion. So just opposite to this forward motion, okay, will have drag force. So drag force will be just opposite, okay, and this opposite will be, this will be the drag, and here we'll have for direction what will be the force? Thrust, because it will propel the body in forward direction. Okay, forward means upward. It is mentioned vertically upward. So what is the relation here? T is equal to D plus W. What will be the L? Lift force, lift balancing force. You can check. Is there any component sine, cos, any component you are getting? No. That L will be what? Directly 0. Why I am showing this? Because here also easily you can understand L is equal to what? W cos gamma. What will be the thrust? Thrust will be drag plus W sin gamma. What is the mean of vertically up? If I say vertically up for this diagram, it means gamma is what? 90. If you keep 90 here, so it will be what? W cos 90. What is that? It is 0. So because this is very usual diagram, okay, so maybe in examination that word you may not able to understand, you draw the diagram vertically up, it is mentioned, so gamma you make 90 degree, and you know cos 90 is 0, so lift is what? 0. Otherwise directly you draw this diagram and resolve the forces. So for this vertical forces, like thrust is equal to drag plus weight. That is correct. Like here, see, if you keep here gamma is equal to 90, so sine 90 is what? 1. So T is equal to D plus W. This equation you make it. So it is satisfied. So what is the lift? Lift will be 0. So what is the correct answer? Equal to its weight, because they have mentioned that lift on an aircraft. So basically, they are asking lift force. So lift equal to its weight? No, it is a steady level. If it is equal to weight, lift is equal to weight means it's a steady level. No, it is not a steady level. It is climbing and exactly vertically up. So this will be wrong. This lift will be 0. Hope you understood. Equal to drag, lift cannot be equal to drag. Equal to thrust, that cannot be equal to thrust. So obviously, this is the one case which is for steady level. Lift is equal to weight. That is true, but it is for steady level flight. But this is not level flight. This is the climbing flight, and very especially special case, that is vertical up, means gamma is 90. You just basic equation you draw and resolve the forces. Automatically, you will get your answer. So what is the correct answer? Correct answer is nothing but option B. Hope you all understand this. All right. Now, this is next problem. This is for 2 marks. Okay. The same gate 2011 it was asked, and question number 40. And this is for 2 marks. We'll read this problem, right? An aircraft with a mass of 5000 kg. So I will write the data also. 5000 kg. Takes off from sea level. Okay. Takes off from sea level with a forward speed of V is equal to 50 meter per second. So I must say this is what 50 meter per second. Forward speed. Okay, we just say V infinity, better. Forward speed, and starts to climb with climb angle of 15 degrees. Starts to climb with a climb angle of 15 degrees. So okay, gamma it is given 15 degree, no? Climb angle. The rate of climb and excess thrust available. So what we need to calculate? We need to calculate rate of climb, which is also called ROC, and excess thrust. Very special. I will tell you what is the excess thrust or excess power. Is very important. No? Thrust available at the starts of the climb respectively. G is given. Okay, G is given. All right. Okay, so hope you all understand. This is the like very nominal case. I mean that aircraft, one aircraft is there and mass is given, and that aircraft is what going to take off from sea level. So that time forward speed is given. Okay, what is the forward speed? 50 meter per second, and now it is starts to climb. So that climbing angle is given. Gamma is equal to climbing angle 15 degree, and they are saying like what is the rate of climb and what is the excess thrust. Okay, this is for 2 marks, guys. So we'll start now. Simply we'll draw the climbing case. So this is the climbing of the aircraft. Okay, this is the climbing of the aircraft. I must say this is the angle gamma, which is called climbing angle, and it is climbing with velocity v infinity. All right. Now, so this is gamma, and very important that weight will be acting downward. Okay. So and lift will be perpendicular to velocity. So this is the velocity. So where will be the lift? This will be the lift force. This is the lift. Now where will be the drag? Drag will be just opposite to the forward motion. And you just check this. If this is gamma, so obviously this angle will be gamma. So we can write this is what W cos gamma, and this will be W sin. Why I'm doing this? Because in this way you can resolve the components, so you can equate. That is our basic mathematics. And another thing, I will draw the diagram, another diagram, triangle based, so that easily you can calculate that what it is called. You can apply trigonometric relation. That's the only reason. Okay. So here you can apply trigonometric. Check, this will be what? Climbing angle. What is this component? It is nothing but v infinity. So climbing means it is gaining the altitude. So this altitude, at the same time, if it is gaining altitude, so it will have a vertical velocity also, and that vertical velocity will be in upward direction, obviously. So that is called VC, and this VC is nothing but uh, climbing speed, you can say, or say rate of climb. VC is nothing but climbing speed or rate of climb. So what is the VC here? It is nothing but V infinity sine gamma. Yes or no? Check. Sine gamma is equal to Vc by V infinity. So what is the Vc? Vc is equal to V infinity. So this Vc V infinity sine gamma is nothing but it is called as a rate of climb. What it is called? A rate of climb. Okay, rate of climb, which is called ROC, which is called Vc, which is nothing but V infinity sine gamma. I hope you all understand this. Anyway, now what here they have asked first, they have asked what is the rate of climb. So first we'll calculate rate of climb. So from this you can calculate. Second, I will write, because they have asked excess thrust, right? So excess thrust they have asked, so I will write the equation first. Completely I will resolve the component and I will show you. So what is the L? L is nothing but W cos gamma. What is the thrust here? Thrust will be the forward component. I must draw here. Thrust will be forward component. So thrust is nothing but drag plus W sine. I must draw neatly. Maybe those who are new, for them it should be very clear. No? All right. Should be very clear. I change the color, then it will be more clear. See, perpendicular to velocity will have a lift force here. This is say CG. This is nothing but gamma angle. So this component will be W cos gamma. Forward, in direction of velocity, forward motion will have one force which is called thrust. Opposite to that velocity will have a opposite force which is called drag. I think now it is clear. No? So L is equal to W cos gamma and T is equal to D plus W sin gamma. Yes or no? All right. Now, so you can check what is the, from this second equation. This is equation number one and this is second. So from second equation, what is the sine gamma? Check. Sine gamma is nothing but T minus D divided by W. Yes or no? T minus D by W. All right. Now, so this is thrust and this is the drag. Both are forces, right? Both are forces. So this T is nothing but, you can say T, this is the TA, which is nothing but available thrust. What is the thrust available in the engine? So T minus drag. Drag is the like a opposition force. It's a opposition force, yes or no? So what we have available, suppose you just for example, I have 200 a Newton available force, and opposition force is what, 150. So it is 200 minus 150. So that 200 minus 150, which is nothing but 50. So that 50 will be the excess amount of the thrust we have. That's the mean of it. So T minus D, this is nothing but excess thrust. I hope you understood this. This is what excess thrust divided by W. All right. I think you are agree with this. This is called excess thrust. So basically, if you want to calculate what is the excess thrust, okay, so it is nothing but T minus D, and it is nothing but W sin gamma. Yes or no? It is W sin gamma. Then now we can calculate this value. Okay. So this is number one, and this is number two. So first we'll calculate rate of climb. It is nothing but VC. It is nothing but ROC, which is called V infinity sine gamma. Check what is the V infinity here. That V infinity is given how much? 50. Let me write here. 50 into sine. No? Sine gamma is given 15 degree. Gamma is given 15 degree. So it is 12.94. I must write here 12.94 meter per second. This is the first. Now we'll go for the excess thrust. What is the excess thrust? T minus D. What is the T minus D? Check. It is W sine gamma. What is W? Mass is given mg sine gamma. We'll write this. What is the mass? 5,000. Let me write 5,000 into 9.81 into, okay, into into sine 15. How much it is? It is 12,695. 12,695.07 Newton, or you can say 12.695 kilonewton. This is the rate of climb and excess thrust. Yes or no? Check. 12.94, 12.94 both. 12.69. Check. We have option B. See both 12.94 here. 12.94 and 12.695 kilonewton or 12.695 Newton. Simple. So it is given 12.695 or 94 Newton. So this is correct. Yes or no? So what is the correct answer? Correct answer is option B. Answer is option B. This was for 2 marks. Here I have taken time because I am explaining the problems. Okay, I am giving the solutions step by step. In examination, hardly it should take two to 3 minutes. Within 1 minute, you just within 30 seconds you draw the diagram, climbing, you resolve the forces, you write the equation, and start calculation. So hardly 1 or 2 minutes it will take to calculate rate of climb, and then you can calculate excess thrust. The important is you draw the diagram, resolve the component, and you should understand what is the mean of excess thrust. Obviously, rate of climb you can calculate. It's a simple one only. Excess thrust, that term you need to understand. You just finish this problem within 2 to 3 minutes. That's all. All right. Hope you all understand this. Now we'll go for next problem. This is the problem number 41. This is again gate 2011, and it was asked for 2 marks. All right, it was asked for 2 marks. So, all right, read this problem. A glider having a mass of 500 kg. So this is not aircraft. This is the glider. Okay. In previous problem, check that previous problem. That's the reason I'm saying like statement are very important. It was aircraft. See, it is given. It was aircraft, but it was performing an unpowered gliding. Okay, it was performing the gliding motion. Okay, or that attitude of the aircraft was a gliding. But it was actually aircraft. But once it was gliding, it means that power was turned off. It was jet engine, so thrust becomes zero. But actually it was aircraft. Hope you understood. All right. But here in this case, and that's the reason, okay, here it is given, read the problem. So that's the reason in this case, it is a glider having mass of 500 kg. So yes, for glider, obviously there will not be any rotatory component, no engines, nothing. So, and it is for very small, for definitely only 1 or 2 seaters. So that mass will be very less, and you can see here this is 500 kg. You can think any a big aircraft possible for 500 kg? No, not possible. So you just go through the statement and try to realize the problem. That's all. It's a simple one only. Okay, they can twist by the statement one. If you read it properly, you may understand easily. Okay. Anyway, so we'll solve this. A glider having mass of 500 kg is taken to an altitude, okay, of 1000 meter with a jeep moving on ground, okay, at this much of the speed here it is given, okay. Now, check. Now, uh, upon reaching the required altitudes in 50 seconds, okay, the glider is released and it starts its descent, obviously. Because glider will not have any power system, so you have to go with some altitude, and then you have to release this, okay, then it will start flying, and that flying motion will be descent flight. I mean, it will lose the altitude because it will not have engine, okay, system, so it will not gain altitude, it will lose the altitude. Once aircraft motion is what losing the altitude, it is called descent flight. Here it is mentioned, this is called descent flight. Descent flight means losing the altitude, all right. Anyway, so now that under the assumptions of equilibrium glide, the range and endurance of the glider for a constant lift. Anyway, so here given quantity we need to write first. So that mass of the glider is given how much? 500 kg. All right. Altitude is given how much? 1000 meter. From where it starts gliding. Okay. Velocity, it is given how much? It is 54 kilometer mph. So we will convert 54 5 by 18, so it becomes 15 meter per second. All right. Okay. Upon reaching the required altitudes in 50 seconds, so time here given, okay, that time it is clearly mentioned, like upon reaching the required altitudes in 50 seconds. So time here it is clearly mentioned. What is the time they have given? 50 seconds. So the glider is released and it starts its descent. Okay, now here after this uh, releasing, that glider will start its descent under the assumptions of equilibrium glide, and range and endurance we need to calculate, okay, of the glider for constant lift to drag ratio, and L by D they have how much? 15. Okay, what we need to calculate? We need to calculate number one, range. Number two, we need to calculate endurance. Okay, all the story here it is given like we are using jeep and reaching to uh, some altitudes, and from there we are going to release the glider, and it starts descending, okay, descending flight, and then need to calculate what is the range and endurance. So in this case you simply do one thing, check what we have to calculate range and endurance. So you know the glider, okay, suppose this is the exact location of the glider, okay. Here we have glider infinity, and you just say it starts gliding, huh? It start gliding with gliding speed, okay, infinity, and gliding angle is what you can say, gamma. So you know very well how to resolve this because it's glider, so definitely and it is at an altitude. What is the altitude? You just say that altitude you can consider here. Suppose glider is got here, so it start gliding. So it is at 1000 meter. at some hill point or some altitude which is nothing but 1000 meters. So how to connect this problem? See, it's very simple. Better I will draw this separately, or better I will draw another triangle. Here I just want to resolve the component so we can proceed. Anyway, so we can say this is v infinity. So obviously this glider will have a weight because mass is given. So weight is what, downward, and lift will be perpendicular to the motion. And what will be the drag? It will be opposite to the motion. And here definitely this is gamma gliding angle, so this will also be gamma. So this component will be w cos gamma. And here this side, this component will be w sin. Yes or no? So you can say like we'll resolve the components. So what we'll get? Check. We'll get w is equal to d is equal to w sin gamma, and l is equal to w cos gamma. What will be the tan gamma? Tan gamma is equal to d by l. Yes or no? That you know very well. And if I want to draw the like triangle based diagram for this glider, so I must say this glider is what starts gliding or descending flying at one altitude, and that altitude it is given how much? 1000 meter. Yes or no? And obviously glider is what starts gliding, so it will glide and it will reach to destination, and that gliding angle you have assumed gamma. So this is nothing but, you just say this is the range covered by the glider, okay, horizontal distance. And obviously this is nothing but altitudes from where it is released. All right, so this altitude I'm saying h. So h they have given to you how much? 1000 meter. Range we need to calculate, okay. And what time it will take to reach destination, that is called endurance. And that also they are asking, range and endurance. Very simple. If it is descending, so there will be vertical downward velocity, just like if it is climbing, the vertical upward velocity will be there. For descent flight, here suppose it is start gliding here. This is the glider, suppose. So it will have a vertical downward velocity which is called vd. What is the vd? Vd is nothing but descent velocity, or called rate of descent. All right, anyway. So we have two diagram. This is figure 1, and this is what, figure 2. So from figure 1 you got tan gamma is equal to d by l, and from figure 2, what is the tan gamma? From figure 2, what is the tan gamma? Check. It is h by r. It is h by r. So first of all, from this is equation number 2. Another, from figure 2 only, figure 2 only, you tell me, if I say distance is what traveled h, okay, from a to b. From a to b, what is the distance traveled? It is h. With what velocity? vd. If I say what time it has, that glider has taken, so that is the endurance, right? That glider, what time has taken, that is nothing but called endurance. Yes or no? Endurance is the time only, what time it has taken for descents, complete descent, then that is the endurance. So from the second figure only, what is the vd? What is the vd? Descent speed. Yes or no? So vd is nothing but, for the gliding, distance is nothing but altitude, and time is nothing but endurance. I hope you understood. So what will be the endurance? It is altitude. What is the altitude? You have taken h. What is the velocity? Vd. This is equation number 3. So here I have given especially three equation, 1 2 3. So we'll start from equation 1 and 2. Okay, from equation 1 and 2. What is the one? Tan gamma is equal to, check, tan gamma is equal to d by l. Tan gamma is equal to d by l. All right, and we know from equation 2 tan gamma is also is equal to h by r. Yes or no? So tan gamma is equal to d by l is equal to h by r. So from here, what is the r? What is the r? It is nothing but h divided by d by l. Yes or no? Or h l by d. Hmm? Or h l by d. So what is the r? R is nothing but range that you have to calculate. H is given how much? 1000. And I think L by D is given lift to drag ratio. Check. It is given 15. Remember, it is lift to drag. Lift to drag means this is L by D. Yes or no? We just take that value L by D, and which is nothing but how much it is given? 15. If you solve it, how much you may get? 15,000, or you just say 15 kilometer. This is the range. I think it is clear to all. Now we'll write from equation 3. What is the equation 3? Check. It is endurance, time taken to reach the destination. So it is h divided by vd. H divided by vd. What is h? 1000. Okay. What is the vd? Because that we have to calculate. That we have to calculate. What is the vd? So how we'll get that? How we'll get that? We'll see the triangle. No? Where is that triangle? Here. If this is the gliding condition, descent case, and here velocity is given, take this velocity is given, what will be the vd? This is the gamma. What will be the vd? Can we say it is v infinity sine gamma? Yes. So vd is nothing but v infinity sine gamma. So we can write v infinity sine gamma. All right, anyway, we should know what is the v infinity sine gamma. So first we'll calculate gamma. We should know, because we need to keep here that value. So we know here tan gamma we have, it is nothing but d by l, which means 1 upon l by d, which means 1 upon l by d is nothing but 15. Okay, what will be gamma? We'll calculate 1 upon, wait, 1 upon 15. All right, we'll take tan inverse of this. This is nothing but 3.81. This is what? Sliding angle. Yes. All right. V infinity here it is given how much? Check this. It is given 15 meter per second. Okay. So we'll keep all the value here. So V infinity is given how much? It is nothing but 15 meter per second. Gamma it is given, calculated 3.1 degree. All value you keep here. So now again I will write endurance from equation 3. Endurance is equal to h by vd, or h by v infinity sine gamma. H is nothing but 1000. V infinity is nothing but 15 sine 3.1. 81. Sine 3.81. This is the value. So what is the endurance? We'll calculate. Let me calculate this value. So sine 3.81 into, okay, so into 15, okay, 1000 divided by 0.99. So it is 1002.2 second. So this is what endurance, and what is the range you have calculated? Go back, check. Range is what? 1500, sorry, 15,000 or 15 kilometer. The range is 15 kilometer. Now we'll go for the option. Check. So 15 kilometer, here also 15 kilometer, but time is 601.3. No, which is wrong. No, 1 kilometer wrong. It should be 15. Should be wrong. No, time here. Check this first option. 15 kilometer and 1002.2 second respectively. So this is your correct answer. Jeep here, don't get confused. This Jeep is what basically used to take that glider at an altitude of 1000 meter. Okay, and obviously, if your Jeep is what moving with this speed, 54 kilometer per hour or 15 meter per second, so the same speed glider will also move. Okay, and then it will be released. Yes or no? So and then and that so it will be released from 1000 meter altitude. So from there you have to pick the question, and as usual, like glider problem, how to solve, you just start solving. So here it has so much steps I have written, but not required in examination because this is the solution. So that's the reason I'm writing each and every steps. Otherwise, not required. All the steps you uh, just try to learn only. Otherwise, in examination, you write the equation, draw the diagram, write equation, and calculate easily. You get the value. Okay. All right, guys. So these are the question. Whatever I have solved, it was asked in grade 2011. So, okay, do hard work and keep practicing. All right. So thank you all. Thank you so much.